Hello everyone. In this video, I'm going to talk about linked list cycle question. It's taking some time to load. Let's refresh the list. Yeah, second question in the linked list set of questions in 75 lead code questions. So yeah, let's start. Let me share my screen. So yeah, in every question I follow these steps, and let me highlight these 7 steps. So yeah, I'll start with the step 1, which is read and understand the question. Okay, so let's start. Given the head of a linked list, determine if the linked list has a cycle in it. All right. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Okay, note that pause is not passed to the parent. Okay, return true if there is a cycle in the linked list, otherwise return false. All right, so it's next thing I do usually is figure out the input and output. So input here, if you see, it's just like a pointer to head. So basically a pointer of node class, whatever it is. And output, what they want in this question is just a Boolean in Java, or just a bool in C++. So let's look at a few examples first now. Moving on to the fourth part, let's look at some examples. This list has a cycle in it. Yeah, we can say that. This also has cycle in it because this node's next pointer is this pointer. Now this is the tricky part, right? Because there's only one. But if it's pointing to null, then there's no cycle. So yeah, that looks good. Now, next thing is the number of nodes in the list is rich. This node value is this. Okay, so node value can be 0. All right, so let's see. Now, one thing we need to check here is, does this list contains duplicate? Let's think about it. Yeah. So if we want to detect the cycle based on the numbers, then it matters that it consider a duplicate or not. But if in the question it's not given, let's say it contains duplicate. So in that case, we need to compare the pointers because the address of this is gonna be same and it's gonna be unique. Let's say let three list is this 3 2 3 2 3. Then address is x1, x2, x3, x4, x5. These pointers will be storing that. So rather than comparing the values, we'll compare addresses. And if anytime two addresses comes to as the same, then we'll say, oh, okay, the next pointer points to some old address that we know. So yeah, a cycle exists in this linked list. So yeah, what can they give you is like a null pointer. Let's see about cases. They can give you just linked list of one item. They can give you a linked list of anything more than one, but does not have a circular dependency like circular link, or it can give you a circular linked list. All right. So one way to do a brute force solution is that let's talk about brute force. So what we can do is create a map of int comma int, and or if you want you can just create a hash set, I would say. And then what we can do is, while we iterate through the linked list like this, what we're gonna say is every time we come to this pointer, like a new node, we'll say, all right, does this new node exist in the set? If it doesn't, then we move forward and put the address, let's say x1, x2, x3, x4. We push the address x1 here. We come to the next one and say, all right, does this address already we've seen? Set will say no. Then we move forward. We put x2 in the set. Same with x3, x4. Now, if the cycle exists, the case will be that will come here, say nothing exists, we put x1, we go there, nothing exists, x2, x3, x4. So we put x3 because there we are only receiving them once. And then it because next pointer is pointing to this, we'll come back again here and we'll say, all right, does x2 exist? It does. That means a cycle is detected. That means that we came to a memory which was already present there. So that's a brute force. Now the thing is that this will take big of n plus this is the time and space is actually it will take big of n plus 1 and space complexity will be uh, big of n2 worst case scenario because we are taking a set, a hash set, and hash set insert and find are big of 1, so we don't have to worry about that. So yeah, big of n time and big of n space. Now whenever linked list comes as a question, I always try to only solve it through pointers, and luckily in this case we can solve this question like a pointer. So let's we'll do two things, slow and fast pointer here. So let's say this is the list. 1, 2, 3, 4. This is the list, and this points to null. Now we'll come here. Every time we both will start from here, slow and fast. And every time we increment slow by 1, and we increment fast by 2. Let me use different colors for both. Oh my bad. So let's say this is slow pointer. This is fast pointer. Then when we go forward, slow will come here and fast will come here. Then because fast, still slow takes 1 step, while fast takes 2 steps. Now, yeah, after this move, slow will come here and fast will go there. After this move, slow will come here and fast will just point to null. So anytime our fast pointer points to a null, then that means that we have reached to end of the list and we can say, all right, uh, no, what's that thing called? No cycle is detected because one of our pointer actually ended up at being uh, at the end of the line. And let's do the same loop. If let's test the same thing if a cycle exists. Oh, that's cool. Yeah. So that's the cycle. Now slow, and let's use a different color for this. Let's say fast. Now what's gonna happen is we move slow 1 point and fast 2 points. Now next next turn, we, actually sorry, we put slow here and we put fast here. Now next turn we put slow here, and guess what fast gonna be here and here back. So anytime a cycle exists, what's gonna happen is slow and fast will eventually come up at the same point within a big of n loop. And as soon as you say, all right, yeah, as soon as you see slow equals to fast, you're gonna say, all right, loop exists. So there are two conditions in this code. If slow is equals to fast, that means loop exists. But if while traversing fast becomes null, that means loop does not exist. So now if you think about it, big of n way, we can solve this question. And because we only had to travel till here and the fast pointer already caught us back to where it was. So Worst case scenario is big of n of this algorithm, and its reason being, let's take a circle. If you start from here and you take one step at a time, and some other person take two steps at a time, then eventually, let's say you were here. Actually, let me actually do it that way. Yeah, slow, and this is fast. Now, if you both start at the same time, right? So then slow will here go here, fast will go here. Then slow will come here, fa fast will go here. Then slow will come here, fast will go here, and then slow will come here, fast will go here. If you see in one loop, slow and fast were exactly once at the same spot. So by the time slow will be done with the first loop, F will find him or her, whatever. Yeah, it will find him. So that's the now it's not like that. You if you want, you can add multiple steps here. Let's say these are the steps, right? Now you can say slow and fast both start here. Then slow moves here, fast moves here. All right. 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 Slow moves here, fast moves here too. They found each other before slow actually did an entire cycle. So yeah, that's the logic behind this algorithm. And let's code it out. So let me write the pseudocode for it. So let's say head is the pointer. So we can say slow is equals to head, fast is equals to head. And we're gonna say, now this is the loops condition. Basically, fast is the one pointer that's determining us if the list exists or not. So if fast exists and fast next exit that exists, that means the list is still going on. So let's say if fast exists, fast is not equals to null. Because what's going to happen is, let's say there's only two lists, right? Like one and two. Starting from here, you're going to put slow here, but fast will end up being null. So because fast moves through type. So for these cases, you have to check fast is not equals to null and fast next is not equals to null. That means that this loop will always run in case like this. 1, 2, 3, 4, 5. Slow, fast. This is not null and this is also not null. That means that your list is still going on. We can still run another loop. Basically, we can still put fast to either some node or null. If it's nothing, then null. So that way we avoid our null pointer exception. While this is true, what you would do is first, actually, let me think about it. Initially, they both will have the same, right? So what we can do is we can just say heads next. Actually, let me think about it. Fast is not equal to. So what I'm trying to say here is like if slow is equals to fast, yeah, then return true. Or else slow will become slows next. Fast will become fast's next. The next. And if worst case, this loop comes out, we'll say return false because we did not break the cycle. Now this code has a loophole, which is the first iteration itself. Because once, according to our code, slow and fast both pointed that fast is not equals to null, this is not equals to null, then it is just going to return that. So instead of starting that, we might as well start from a lead. But in that case, we need to figure out this code early. Let's say if head is equals to null, or heads next is equals to null. In these two cases, we're just going to return head. If this is not the case, then it means that at least head has 1 and 2. So we can start slow as head and fast as heads next, next. And if there is only 2 items in the list, then this will never run and this will fail. And actually, let me think about it. There's one more edge case. We need to figure it out. Yeah, actually, yeah, that's true. If it has a cycle, let's say, if it has a cycle, then head will be sorry, slow will be pointing here, but fast will be pointing here. So basically, fast will not be null, and fast next will not be null. And here it will detect this. So yeah, this looks good. But if it's next to null, then what's going to happen is slow will point here, fast will point here. This loop will never run. So yeah, this looks good. And let's code it out to see if it's as good solution as you think it is. Let's say next node pointer is slow. Another one fast. All right, now what we're gonna do is head. If head is equals to null, what did I do again? Or head, and this is next, so which is good. Then we're just gonna return head. If that's not the case, then we're gonna say slow is equals to head. Fast is equals to heads. Next, next. All right. And we're gonna say while fast, actually we can just leave like that. And fast next. Actually, that's C plus one implicitly checks for null, so let's not write that. And what we're gonna do is if slow is equals to fast, return true, as slow is equals to slows next, and fast is equals to fast. And once this is done, we can just say return false if nothing happens. So yeah, let's look at it. If head is null or heads next is equals to null, return head, that makes sense. If this condition does not meet, that means head's there, heads next is there. Let's say what if only one node keep pointing to itself, then head will not be null and heads next will not be null. But this will be always pointing to slow. Yeah, makes sense. All right, so this looks good to me. Let's quickly see. Hmm. Let's see. Is there some error happening? Let's debug this. What's happening? Let's try to paste this code and see if this one works. Then there's some bug in our logic. Is there a lead code issue? Oh, well, I refreshed it. Let me write that code again quickly. Oh god, I lost it because I refreshed it. Yeah, let me quickly write that down again. All we did was this node pointer slow and then fast, and then what we did is if head is equals to null for our heads, next or else we say slow is equals to head. Slows actually, and then quickly we run a while loop. Actually, my bad. And say all right, this is what I think the code was. Slow slows nice, return true. Let's run the code. Let's see. If it's only one, oh my bad. Return. I'm returning head here. If head is equals to null, if head's next equals to null, yeah, my bad. This would be a boolean. If head is equals to null, then we're gonna return. Let's see if we can break this condition down. If head's next is equals to null, that means we still return false. And let's run it now. Actually, we can just do this. Let's see. Yeah, all right, it worked. My bad, should have been returning false from here. But yeah, if you look at this code though, this is, they are not even doing this manipulation, they're just starting from slow and head. And rather than this code, rather than calculating P1, P2 at the beginning, they're calculating after they move it. So yeah, I think that works too. The thing is P1, yeah, actually that works too. Even if P2 is null pointer here, it's not going to be equal to that. So yeah, that works too. So yeah, if you don't want to initialize this code up here, you want to just take care of it like this, that works too. But actually in this code, position is never used. So yeah, pretty fast solution. Ours is much faster than that, but yeah. Thank you everyone, and let me know if you have any questions.